it looks like we've got a paltry crowd tonight, but I was explaining to Stephen that we're recording tonight, and our guest tonight is Stephen Brenner, and he is a non-game biologist for Audubon, I guess now. So he has worked with Joel Jorgensen, who has joined us tonight, and he's going to speak to us about the FAD and the migration stopovers in wildlife areas in Eastern Nebraska. Some original research that he did while working with Joel. And he currently is working with Audubon, Nebraska, which is kind of near and dear to our heart. So I will let Steve get started and we'll sit back and enjoy. Thanks everybody for coming.
Great. And thank you, Bob, for that introduction. And thank you everybody for showing up, or if you're viewing later on, whatever works. Glad to be here presenting on a fun little project and a topic near and dear to my heart, just something of, endless interest, I would suppose, and that's songbird migration, especially in the eastern part of the state. And as Bob was saying, this was some work that over the last 2 falls in 2021 and 2020 that myself and non-game bird program manager, general birding superstar Joel Jorgensen and I completed outside of Lincoln. So without further ado, let's go into that. But here we are. Great. Okay, so bird migration. No matter what it is or how you're looking at it, this is truly, I think, one of the more just fascinating and amazing, natural spectacles that we have. And with birds especially, it spans across all taxa. You got cranes, geese, shorebirds, raptors, and of course, songbirds, sort of the focus of today's talk. And, in the context of this, we're going to be focusing on neotropical songbird migrants. And in the sort of North American context, it's birds typically breeding in the sort of northern and boreal forest that would be wintering all the way down, usually in like Central America, South America kind of region. And oh, there we go. Right. Oh, sorry. And to put this into, I would say, to really like visualize this, we're talking about going from breeding areas, which are typically really high resources, to non-breeding areas, also usually very high resources, lush and green. I have 2 photos here. This is a northern forest in Montana. As you can see, lots of trees, lots of green. During the wintering times, this is a coffee farm in Nicaragua, also lush, also green. But in the in-between, who knows with that journey, what could be going on. So you never know what these birds are going to get. And that in and of itself poses particular challenges. There's many other challenges going on here with fall migration. Probably the biggest to any bird is going to be body condition. Like, are they fit? Are they ready to go? Can they make the journey themselves? So of course, the breeding season, lots going on. You got a lot of responsibilities and energy to expend. And then after that, birds are typically going to molt, which is a whole physiological process in and of itself. And then they got to get ready to make this, 100 to 1,000 kilometers-ish journey across the continent. So, I highlight blackpoll warblers here because as a fall migration for a songbird, I think they have one of the craziest and coolest, they, regardless of the population, they kind of all move to about the mid-Atlantic, Delmarva Peninsula area and fly nonstop over the Atlantic to get to South America. And again, this is like a 15-gram animal we're talking about. So moral of the story is you got to be in really good shape or else you're just not going to make it throughout the whole journey. And sort of related to this is your diet along that migration, because fat is the main fuel source for songbirds on migration. And, with that diet, you need to pick up foods with lots and lots of fat, but not just fat. Sometimes if you can, if you can get a diet that helps you with recovery as well, that is also a big challenge and a big thing because, these are huge long distance exercises, and any animal that, metabolizes, that comes at a cost of potential oxidative damage when you're exercising. So if you can get food that's rich in antioxidants, helps protect the body, you reduce the damage a little bit, and you get the fat for fuel, bada bing, bada boom, you're in good shape. Weather, of course, always an issue. You don't want to fly into a hurricane, but birds on migration, particularly fall, when there isn't the sort of rush and, big need to get to the breeding grounds first, they are always going to try to take advantage of wind profit and use winds that are going to be tailwinds. So what that means in fall migration is, these birds are heading south, so they're going to wait for a north wind in order to, continue their journey on south. If there is a headwind, so if there's a south wind, birds are typically not going to try to migrate into a strong headwind. So moral of the story here is that north wind, generally a good idea to get moving. South wind, you don't want to go through that. And these are nocturnally migrating birds, so it's the weather kind of in the evening time that they need to be concerned about. And then, of course, experience. Fall is unique in that you have a bunch of birds on the landscape that are totally new to this game. The previous summer, whole bunch of eggs laid, fledglings raised, etc. So, these guys have never been around the block before. They're going south for the first time ever. Whereas your adults, they've done this at least twice. They went south their first year and then came back up to breed. So an interesting dichotomy there, and just again, yet another unique challenge of fall migration. And the big take home here again is the food element, the dietary element, fat. Fat again is so key and critical for these birds on migration. And we just live in a glorious time. Last 20 years has just been this explosion in research on fat, everything from, the molecular level up to the whole organism. We're talking just all these like intertwined things of weather, habitat, just amazing, amazing work. It's winter time right now, might be a slow day, put on a pot of tea, go to Google Scholar, go nuts. Just some really great work out there. This is just the tip of the iceberg. So the point being, though, that we are now much more aware and ready and looking at just how important fat and diet and all this stuff and stopover, all this stuff, how important it is for birds on this major event in life. So speaking of stopover, migratory stopover is the other theme, I suppose, of today's talk. First off, the definition, I guess, and to avoid any sort of academic disagreement or whatever, I think just simply think of migratory stopover as just anywhere the bird is at when it's not like actively going south. So when the bird's flying, it's obviously not on stopover, it's migrating. But when it lands somewhere and hangs out, we'll just think of that as stopover. So what exactly makes good stopover? Well, no surprise here, food, very important. Can you get fuel up? Can you recover? Can you do that? Habitat structure is a big one, kind of related to food. And thinking of habitat structure, think structural diversity. For migration, typically speaking, you want this sort of multi-layered, grassy forbs, shrub is really nice, maybe some mature trees. This provides obviously variety of chances for different types of forage, but also just protection. I mean, any time of year, anywhere, lots of things like to eat birds. So, birds can get a chance to hang out and be safe. They're going to take it. And location, as always. And location really relative to the migratory path of the species that we're talking about. I highlight here some more famous examples. You got Cape May and High Island. But a good stopover, a critical stopover spot doesn't have to be surrounded by ocean necessarily. It's just, again, this location relative to a lot of things. So all very important stopover. And I would say in Nebraska, we're actually almost certainly familiar with this and kind of spoiled, honestly. We get one of the more obvious and huge stopover spectacles every spring in the sandhill cranes. And I would contend too, some years with all the geese and ducks and sometimes shorebirds in the rainwater basin, we get these big, massive flocks of things hanging out, staging their journey as they continue north. And it's just an amazing sight. And Nebraska is awesome for that. But as we all probably know here, sandhill cranes and like a black-throated green warbler are just like very different things. They require very different things on their migration from, food, habitat, et cetera. So first, Joel and I got to thinking about, okay, well, we're not really talking about stopover in central Nebraska. A lot of these species, these neotropical migrants in our state, when they migrate, it's really more towards the eastern end of the state anyway. However, that eastern end of the state is predominantly an agricultural landscape to a massive degree. And, it's like a monoculture. It's usually like corn or soy or something like that. So yeah, this eastern part of the state, you have a lot of this like human altered environment. Joel and I put our heads together, which can be a dangerous combination sometimes, but we got to thinking, well, where might there be stopover? Wildlife management areas. Yes, WMAs, typically the target there is game species. Think like bobwhite or something like that. But if you're managing for that, you're going to have things like some shrub. You're typically going to have, native grasses, forbs, things like that, maybe some trees. And again, keep in mind that this habitat in an ag dominated landscape. This is sort of unique in this larger area. So the ingredients are there. You would suspect that because there's this habitat diversity, because there's all this stuff, why wouldn't songbirds use it on migration? However, we've never formally really looked at that until now. And just kind of the overarching basic question that we had was that, are these wildlife management areas in eastern Nebraska, are they going to be good for stopover for songbirds? And sort of the basic way we went at this is kind of from a body condition thing and a very simple assessment of body condition, and that's fat. Basically speaking, the more fat you have, the better chance you have of making that journey. So thinking about that and the importance of fat, our sort of main questions here were that, or our hypotheses were that, so birds that would be arriving theoretically at the WMA, meaning that we had a night of north winds. And again, most birds in the fall, when there's a north wind, they're going to be moving. Those birds that we catch, they should have low fat scores. And that's almost expected in most places, I would say, in North America, unless you have like, there's some specific locations where things are a little different, but you would suspect for the most part, after a night when birds are moving, they're going to use a lot of their energy and their fuel reserves. They're going to have low fat. The flip side there, that's the important part of this, is that we would suspect that birds banded after an evening of south winds, meaning these birds were on stopover, those birds should have higher fat scores, meaning that, okay, there was a headwind. Most birds are not going to be moving in that. They're going to be stopped over wherever they landed the day before. If those birds are at a good stopover site, they should be fueling up, they should be recovering, they should be building those fat reserves. So that's how we went about assessing whether or not a wildlife management area, a typical one in the eastern end of the state, if that's going to be benefiting songbirds on migration. So that was really the main question and the main thing we were looking at. But as you're banding birds and collecting data and all this stuff, we took just thought we'd throw in a second question, which is about birdcast. And I'm not sure how many here are familiar with birdcast, but it is essentially, I guess in their own words, a way to predict bird migration and kind of forecast that in real time. So what does that mean? They're using essentially radar data, which radar can actually pick up birds in migration, which is really, really cool. And they're using, weather, atmospheric stuff models, et cetera, time of year. And, the purpose of this is it's a very strong and I think super neat conservation tool, because you're taking this, alternate data set and really turning it into action for the birds. So, this has been well published, and it's tightly associated with this Lights Out campaign, which again, not sure how familiar we are, but essentially you will use this birdcast forecast and it's like, oh gosh, it really looks like conditions are great for birds to be moving tonight. Hey, city of Omaha, if we can dim the lights a little bit, that really reduces the chance that the birds are going to get off course or be attracted to, and they run into skyscrapers, buildings, et cetera. And this is just a great idea, a proven campaign. They've been doing it a bunch. They do it in New York City, Chicago, Houston. It's a really cool thing. So that's the primary focus of birdcast and what it's used for. But these are like a migration forecast, and if you've ever seen them, they kind of come in some basic flavors of like high, low, medium, and that intensity of the colors there is sort of predicting when you're going to have good migration, and you can check it for a specific area in that. So that just kind of led us to a simple question like, well, okay, if there's a high birdcast forecast, are we going to see more birds in the morning? Is Joel going to get that awesome bird that he needs the next day? But just a pretty straightforward look. The hypothesis there, we figured, yeah, we would catch more birds after a high predicted birdcast forecast. So where were we? How did we do all this? Our study site was just southwest of Lincoln at Conestoga WMA. I'm sure some of us have maybe been there and birded there. And again, we were on the WMA portion, south end of that site. We use mist nets, and for those not familiar, it's essentially these long sort of fine mesh nets. It's a passive form of catching birds. So essentially you set these up, you check them every 45 minutes or so, and you just get what you get. You know, you take the birds out, you process them, you band them, you release them, and you go on to the next ones. And this is pretty representative of where our nets were. We were really in like a shrubby, grassy edge locations for most of our nets. We did have some mature tree line by one, but again, it was mostly centered towards shrub and that kind of field edge sort of habitat. And the stuff we were looking at, catch rate, that's a given, you know, just how many birds given our effort. Species composition also a given. And then the individual demographics. You know, in fall, sometimes sexing these birds can be difficult to impossible because a lot of those traits sort of, you know, dwindle, or just the plumage differences aren't there. But in some species, you can get it. Age, again, is a big one. And, you know, with banding in fall, typically you're looking for things called molt limits in songbirds, which is essentially just a contrast between feathers that were recently molted and replaced versus those that are very worn and have not been. And you can kind of see that a little bit, I think, in this least flycatcher on the left. And then, of course, you have the adult birds, which this is an adult common yellowthroat on the right. We could know that actually by just looking at them, but it's nice to see the wing where you see that there's in the coverts there, no real difference in the color, the shape's about the same, the wear's looking good. So that's the kind of thing you're looking for with age. But, you know, our key measurement, our critical measurement was fat. And the way where you're looking for fat on these songbirds is in the furcular area, which is like below the neck and above the sternum. And birds are great because they store all that fat basically right there, and it's right under the skin. So you blow apart the feathers, and I hope you can see in this picture, but it's literally that yellowish mass right under the skin. And you know, that is how essentially you measure fat on birds. So it is a scoring system because this is a non-invasive technique, you know, the birds and everything. But there have been previous papers that have looked at deceased birds, you know, the amount of fat you score versus total fat composition of the animal. Turns out it's a very tight correlation. So this is a really tried and true way to measure fat overall for these songbirds. And you get used to the scoring system pretty quick. And it is amazing the differences between, you know, you catch a bird, you check it out. It's like, oh, it's got, you know, there's a little bit of yellow in there. There's a nice little base. That's a wee bit of fat. That's nice. And then all of a sudden you get a butterball like this Nashville warbler, and it's like just bursting at the seams. And, you know, that thing couldn't store more fat on its body if it tried. So always really cool to just see that every little bird is different, right? And they're all always doing different things with that. So fat was our sort of key measurement there. You know, we were just doing simple comparisons for kind of getting to our conclusions. That catch rate for whether it was a high or low for forecast, that was kind of an easy one. And then, you know, fat score was our big proxy for our birds, you know, doing well with stopover in Nebraska. And again, that north versus south winds, it's very general. And again, it was any wind with like a northern component. So it was like a northwest wind, we count as that as north wind. You know, if it was like south southeast, that's a south wind in this case. Again, you got to start somewhere. We kind of simplified this. And for the more astute observers among us, you know, you might be thinking, well, banding is passive, you know, this passive banding stuff, you're at Conestoga, like, what about like a cardinal? You catch a cardinal or a chickadee or something. And I would agree. We limited this analysis to migratory birds only. So first step in that analysis is just getting rid of the resident species, essentially, you know, because we would catch cardinals, chickadees, what have you. They're not going to Central America anytime soon. So obviously we process and ban those birds, but they are not included in this. The trickier bit is when you get species that do in fact migrate south, but may or may not breed in Conestoga or in the general area. And the way we sort of eliminated those birds is looking for heavy molt, usually in the body feathers or like an intense molt in the flight feathers. And the reason we did this is because molt is in and of itself an extremely demanding physiological process. And very few birds can molt heavily and migrate large distances at the same time. So there's just not enough energy essentially to go around. So any bird we caught that was like a maybe migratory species, but was exhibiting a lot of molt, we just didn't include it. And to, really drive this point home, why it was a good exercise or a good precaution to take. I took this photo at Conestoga this past June, and I was like in a net lane. And if you zoom in, it's blurry, but you can see that there's a band on that bird. We can't read that number, but given the lack of other songbird banding going on around Lincoln, Nebraska, it's a high probability Joel or myself banded that bird in 2020 at some point. So, we were, and like, again, mostly this was eliminating like things like patchier catbirds that looked like they just molted for the first time. So it was the right move. And again, we were very careful not to include non-migrants in this analysis. So if you're statistically interested, we didn't really, reinvent the wheel on this, some pretty simple stuff. We compared some single factor models on what might be influencing FAT score. Obviously, wind was our primary variable of interest, but we did look at stuff like the time of capture, the date and the year, the species group, stuff like that. And that was with a general linearized model with inflated Poisson distribution for those who are curious. And then when it came to comparing the catch rate of high versus low forecast, that was just comparing averages, nothing crazy there, but you got to do something, I guess. So how did it all work out? What the heck happened here? So that first year we did early September to mid-October, and year two we did a little bit earlier in late August to about the same time in mid-October. By mid-October, most of the neotropical migrants at any rate are more or less gone from our area. Also, like pheasant season and stuff was coming up right around that time, so we just wanted to avoid all that. And we did 25 days with 230 net hours and change. Now, those familiar, maybe you've been to some migratory banding stations. I can, personal experience, I've worked at many a migratory banding station where, you can do 200 net hours in a day. But, all of that's really related to capacity, the size of the site you have, how many people do you have that can work the nets and safely extract. There's a lot to that. This wasn't the only thing I guess we had going on. We had lots of other things and not a lot of resources to put to this. However, given that, I say we put in a really good effort, especially considering we got over 480 birds, almost 40 species, 29 of which were migratory. Those of you who may or may not be familiar with the Nebraska Natural Legacy Project, it has these species of conservation concern, and they're kind of in different tiers, tier 1 being of highest concern. We caught multiple legacy species, some savanna and swamp sparrow, but the real gold star winner was the black-billed cuckoo. There's Joel about to release the cuckoo. But if you've been birding around Eastern Nebraska, probably noticed that that's a really hard bird to get all of a sudden, and they're just not, they're really thinning out. So it was nice to see a cuckoo using our site. I mean, that was unexpected and really a nice treat. As far as the general ebb and flow of a particular fall, both seasons, this is just how our catch was going over the progression of the fall season there at the bottom. And you can see that there's like a definite peak there. And I just kind of highlight this area. Basically the second half of September was sort of when things would get, if they were going to get busy, they were going to get very busy. Obviously you can have pretty sweet migration days before this time, like first week of September, or maybe even like late October. But you're making plans for next fall and you want to go out when there's at least going to be a lot of birds around, maybe pencil in that like third week of September or something. Kind of to that end, Nashville warblers and common yellow throats were, they were our heavy hitters doing the yeoman's work with the numbers there. But Nashvilles are such a great bird. Each individual is different, so that was really sweet. Yellow throats are great. We did catch a lot of catbirds. We'll move on from catbirds. And then again, those big days were sort of that third week-ish of September, right around there, both years. And again, catching 41 birds given like 4 nets and a couple people for just a morning, that's really a good effort, I would say. So the following slides too, I got a little photo collage of what we were catching. Obviously birds are aesthetically really great and all that. So that's enjoyable, but also just kind of keep in mind when you're looking at these, the species diversity here, all the different types of birds that, songbirds that we had using this site in migration. So here's the warblers, obviously, crowd pleasers. And again, not, we caught a lot of orange crowns, not super unexpected given the habitat, obviously a lot of Nashville's, but we had Wilson's warbler. Ovenbird was one I didn't expect out there. That's a morning warbler in the top, which was awesome. Great bird, yellow rumps, tons of yellow warblers. So, even within warblers, we had like a really nice mix. And again, apart from ovenbird and morning warbler, we had multiple of these species here. But warblers always get the attention. So, there are a lot of other stuff that we're migrating through. We had 4 species of vireo, which is really great. Some Impedinax flycatchers, always fantastic. Kingbird, of course. And again, 4 species of vireo with lots of ones in between. I mean, that was awesome. Later in the season became kind of sparrow time, sort of end of September and then October. But I put the stars next to our legacy conservation birds there. We got Savannah sparrow on the top left and swamp sparrow in the middle. White-crowned sparrow, Harris's sparrow working our way down. They started to get really heavy kind of that October area. Clay-colored sparrow. We caught, I think, close to 30 Lincoln sparrows, which I think is one of the most underrated birds out there personally. So that was just a delight and good to see, we had really good numbers of them. But kind of our grab bag here, and again, this isn't exhaustive. We caught, close to 40 species, but, cuckoos, buntings, goldfinches, kinglet, we got 2 species of wren. Of course, some of your resident birds like downy and chickadee. The point here again being just even on this page, things from a bunting to a goldfinch to a cuckoo. This is a nice array of stuff. And generally speaking, if you're going to have high diversity, that's just a good sign in itself. I think typically when we're talking birds that, yes, it's migration, things end up in crazy places. But, again, that diversity is just a really good indication that the site was working out. The more numeric results. So when comparing our catch rate on the high forecast versus low birdcast forecast, inconclusive. We actually didn't see any real differences there, nothing statistically anyway. So that just kind of came out the wash. And we'll talk a little bit more about that in a sec. When it comes to fat, so this is just all the fat scores sort of averaged up and like the general gist of the caught after southwind versus northwind. You can see that it is indeed looking like higher average fat scores catching birds after the southwind, meaning those birds were probably on stopover versus the north. And in fact, statistically speaking, this is just model ranking, meaning when comparing models to each other, which one performs the best. So the lower your AIC score, kind of the better here. And in fact, that model that was looking at wind direction on fat score, that was our best performing model. And subsequent stats after that shows that, yes, it was a significant effect that birds had higher fat statistically higher fat caught after south winds than north. So that's really what we were looking for. That was great to see that for sure coming out. And then we're sort of seeing some interesting thing too with species group there on the fat scores. So like digging into that a little bit more. This is a slightly different figure here. And what this is kind of the fat scores of these species by group over, again, the sort of progress of the fall season. And you can see in that solid purple line, dashed black line, and dotted red line, those are your flycatchers, your warblers, and your bunting, what have you, sort of vireo miscellaneous. And there's a pretty, steady, as the season progresses, these birds tend to have more fat on them. And that makes a lot of sense because, again, if you're, like a warbling vireo or a Nashville warbler, and it's like end of September, clock's ticking, you do not have a lot of time, to get to like southern Mexico. So, you would expect birds to have just higher fat as things go on. But that dashed gold line, that's our sparrows. And it looks like, it's sort of like steady, just decreasing over the season. And that's just kind of odd. But, we took a second look at the species we were catching there of the sparrows. And it's, things like white-crowned and Harris's sparrow. They're just about at the end of their journey. I mean, they winter either in Eastern Nebraska or just very close to there kind of thing. So if you're catching these birds and it's like migration's more or less over, they're not really on stopover necessarily at that point. It's just kind of they're just settling in for the long winter's nap, as it were. So removing sparrows from our analysis actually date does become a significant factor. Birds are putting on more fat, but you can also see, you know, that orange line is birds caught after the south, blue line birds caught after north. There's still that nice big dichotomy there. So that's still a significant effect. And it really becomes clear when you just look at the averages. Average fat score in birds caught on stopover was like 2.5 compared to that right around 1 for birds that were presumed to be moving the night before we caught them. So revisiting the hypotheses there, both with that north winds, birds would have low fat. We figured that. But that really important one of birds presumably on stopover, meaning headwinds, birds wouldn't really be moving that night. Those had higher fat scores. 2 thumbs way up for that. And you know, when thinking about this, I like to, when we're going back to hypotheses, think about, well, what else could have happened that would have led us to different conclusions? Well, like I've said before, that whole north wind thing, again, most birds are probably going to be moving that night. Birds having low fat after north winds, not crazy town, but that's sort of your baseline. You could definitely envision a scenario where we're catching birds on the south winds that are probably on stopover, and their fat's about the same as the birds we would catch on the after the north winds. Meaning, all right, you know, the birds are probably on stopover at Conestoga, but you know, they're maintaining their body condition, but they're not necessarily improving it. They're not, you know, getting better at their next leg south while they're in Nebraska, which could mean, you know, maybe there's not as much food around. Maybe the birds have to travel a little further and expend more energy to get that food. Could be a scenario like that. We could have even had a result where it was a lot of the birds we would have banded on those south wind days would have lower fat than the birds we caught after the north winds, which that would be like a lot more frightening in the sense of, one, that would tell you that, man, you either have really poor quality forage, not a lot of it, or, you know, a combination of those things. Maybe you just have low quality birds that migrate through this area. Maybe they got to travel super far. I mean, maybe it's like an ecological trap. Fortunately, none of those things happened, but you know, it was not a given necessarily that the birds we would catch that were migrating the night before would in fact have the higher fat. So really nice to see. And I gave a version of this talk a few, you know, in another setting, and it was suggested to me to look at another piece to really hammer this home. Did some quick analysis, and it really helps the case here, I would say, because what this analysis is the subsequent days of like same wind conditions overnight. Meaning, you know, that x-axis there is days since the wind shifts from either south to north or north to south. And you can see again that kind of orange line, blue line, those are distinctly on different planes, so we're still good there. But, you know, looking at subsequent north days, birds' average fat score seems to start around 1 and maybe get to like 1.5 in 3 consecutive days of north winds. And you know, that's not much of a difference. And it's also like, well, maybe a couple birds were waiting, you know, to get their own condition up, or just, you know, birds you catch randomly coming in, who knows. But the subsequent south wind days, again, that's, you know, 3 to 5 days of things are not really conducive for movement. So birds are probably haven't been moving around very much when you catch them. And you can see that that fat gets really high. I mean, it starts at about 1.5 on average. And then after 5 days, we're catching birds with an average fat of 4, which is quite a lot. And even after 3 days, you know, it's an average of like 2.5. So this little extra bit really adds, I think, some nice evidence that we're probably heading in the right direction, meaning Conestoga and probably a lot of these WMAs are, if they have certain habitat features, I would say are going to be good stopover sites. As far as the bird cast goes, we predicted we'd catch more migratory birds after a high bird cast forecast. Again, inconclusive. We didn't see any evidence for that. It's kind of going the other way, actually, but again, there's nothing in the statistical wash. Now, why would that be? I think it's important to sort of revisit what birdcast is sort of designed to do and what it's actually doing. So again, it's designed to track migration, enhance these targeted conservation efforts. But again, what that data is, radar is measuring birds moving at night. When you're measuring migration like that, it's the birds that are moving overnight. So these forecasts are about, nighttime migration. And you can definitely have loads and loads of things moving over you, but that doesn't necessarily mean that they're going to land at that location the next morning, the kind of literal definition of flyover, I guess. But the other thing about this too is like it was so easy to predict birding conditions. I don't think we would probably be into birding as much because it just, that would eliminate the surprise. And again, I can't tell you how many times, I've looked at the weather or something like, oh man, it's like mid-May. We haven't had a frontal change in a while. This is perfect. And then I go out, I get like 3 rumps and, a catbird or something. But then there's other days where like conditions look garbage. I'm out at like 2 in the afternoon and it's a little rainy and all of a sudden there's like 8 species of warbler. So, this idea of predicting migration and specifically like how that like translates to birding, again, there's so many factors. It's like where you're birding, like what the conditions were north and south of you, what time of year it is, all that kind of stuff. And, we were sampling birds that would be moving through scrub and grassland and stuff like that. But again, Joel is just going to have to continue to just aimlessly look around the wetland there and hope that he finds that next black-billed cuckoo, I guess. But at any rate, again, predicting birding is a little tricky, I think, is the take home there. The good news, though, again, the thing to really take home is that as far as migratory stopover and the adequacy for songbirds in the eastern end of the state, Conestoga, and I would, Conestoga is not very unique when it comes to WMAs, at least around Lincoln and kind of that eastern end of the state. I think these are probably pretty decent stopover sites for the songbirds in fall. Multiple lines of evidence for that. We got just the sheer diversity, lots of diversity of the migratory birds there. Again, those fat scores, the condition stuff really kind of building up, looking like that. And then this is more anecdotal, but that's my hand covered in bird poop, which is of course mostly berries. And this could have been any day up until the last week of September, in all honesty. So yeah, it's completely, that's not data, but birds are eating stuff at the site. They're pooping it out. I would say it's looking pretty good. And like what that translates to as far as like a management conservation thing is, if you can include any sort of early successional function here, I think in this, that's probably going to benefit migratory songbirds. A lot of work's been done on that too. That's shown basically the same thing in the Midwest and Eastern US. So what's neat about that is it's kind of unintentional, I suppose, in the sense that like, yes, this WMA management's for game birds, game species, but and that's great. And Joel and I have also been working on woodcock, and we in fact caught woodcock at Conestoga right next to our net lanes for the songbirds earlier in the year. But if that's intended for a certain species or a certain group during the breeding season or what have you, but then it also we know that this is really good for all these migratory songbirds. That's just a really nice combination. So this project was a lot of fun. Cool to get some interesting and encouraging results. And with that, thank you so much. And I would be happy to take any questions that anyone may have.
I just have to say that I'm sorry. This is it's really heartening to see the quality of these WMAs for songbirds. I guess I'm always assumed that was going on, but it's nice to see that areas that are maybe managed for other species, the migratory songbird species are benefiting from it. So that really is pretty encouraging.
Yeah, and it's not going to be every WMA in every spot of the state, but certainly when we're seeing like things like dogwood and just like lots of sunflower and goldenrod and stuff, the birds are all over that, and that's where our nets were, and we would just keep slamming them there. So yeah, it was nice that when that little bit of structure and fun is in there, it does seem to kind of bring things in.
And I didn't really mention, I guess we all assume that if you have questions you want to put up in the chat, you can certainly do that. I really, really do appreciate it. This is really interesting research. I know it's been done before, but it's nice to see it, coned down to some local habitat, that we all can appreciate.
Yeah, no, absolutely. Thank you for having me. It was a joy to do, and yeah, just nice to see things, I guess, working as we would hope. But you never know until you check. So.
And thank you, Joel, for offering up Steve for this. It was really interesting. So if there aren't any other questions, anybody's got any they can bring up, we will let Steve go here. He's out west, so we'll we were talking about this being the joys of Zoom. You can get people from all over without having them have to drive the heck and gone. So that's great. So
yeah. Well, thank you so much. Great to be here. And yeah, well, sure we'll be seeing some of the people here.
Thank you very much.
All right. Yeah, have a great night.